All right, good morning, everybody. This is Mr. Shua coming at you again with another math lesson. Today's math lesson is going to be in geometry, specifically the Pythagorean Theorem. Most people have heard of the Pythagorean Theorem, even if they're not sure how to apply it or what it's used for. So I'm going to give you a little bit of background and history on the Pythagorean Theorem and show you how we can use it in order to solve math problems. So now, the Pythagorean Theorem itself is a squared plus b squared equals c squared. What does that mean? That means in a right triangle, here we have a diagram of a right triangle. The A and the B are called the legs. This is leg 1, this is leg 2, or leg A and leg B. And if you square the length of this leg and add it to the square of this leg, A and B, it's going to be equal to the square of side C. Side C is the longest side in any right triangle and is referred to as the hypotenuse. And the hypotenuse is always the side which is opposite the right angle of a right triangle. Now, this theorem is one of the earliest known theorems to ancient civilizations. It was named after Pythagoras, who was a Greek mathematician and philosopher who was born approximately 570 before the Common Era. Now, this theorem bears his name, although we have evidence that the Pythagorean theorem was first known in ancient Babylon and Egypt beginning around 1900 before the Common Era. And the theorem, researchers claim, came into existence much before Pythagoras was born and was also in practice in India and China. So even though this Pythagorean theorem has the name of a Greek philosopher and mathematician born in 570, ancient cultures were using this theorem over 1,000 years before he was even born. But enough of that for now. Let's get into how we actually can use this theorem to help us to solve math problems. So let's look at our first problem here. So it says the diagonal of a rectangle is 40 and its base is 32. Find the altitude or the height of the triangle. So I drew a triangle here. Here's a diagram. We know that our diagonal is 40 and our base is 32. Here's the base. So we want to find the height or the altitude here. So we're going to use the Pythagorean theorem to do so, which is a squared plus b squared equals c squared. Our a, our altitude, we don't know that yet, so we're going to leave that as a variable. Our base b, we know is 32, so that will be 32 squared. And then the diagonal, we know is 40. That's our hypotenuse, equals 40 squared. So let's just use our calculator here and get some information. So a squared plus 32 squared. 32 squared is 1,024. Then 40 squared is 1,600. So a squared plus 1,024 equals 1,600. Now we want to find out what the a is. So we're going to subtract 1,024 on each side here. So 1,600 minus 1,024 gives us 576. So we bring down the a here. A squared equals 576. Now this is what the a squared is. We want to find out what a is by itself, not squared. So what we need to do is take the square root of both sides. So if we take the square root of a squared, that just leaves me a. And square root of 576. So the square root of 576 is 24. So A is 24. So our altitude or our height is 24 in this rectangle. So this was a pretty straightforward example. Let's take a look at another one here. All right, what do we have here? So it says, a fireman's ladder, which is 100 feet long, reaches a point on a building that is 80 feet above the ground. If the ground is horizontal, how many feet from the foot of the building is the foot of the ladder? Okay, so again, another diagram. So, fireman's ladder, 100 feet long. It reaches a point on the building that's 80 feet above the ground. That's our altitude. How many feet from the foot of the building is the foot of the ladder? So we need to find out what the base is. We don't know what our base is here, but we can use the Pythagorean theorem to find that out. So a squared plus b squared equals c squared. Now we know what our a is. We know what our altitude is, which is 80. So if we go back and clear this here. So 80 squared is 6,400 plus b squared. We don't know what our b is, so we're going to leave that as our variable. And then we know that c is 100, so we'll do 100 squared is 10,000. So we have 6,400 plus b squared equals 10,000. So we want to find out what the b is, so we're going to subtract 6,400 on each side. So 10,000 minus 6,400 is 3,600. So b squared equals 3,600. Well, that's what b squared is. Well, we want to find out what b is itself. So we're going to take the square root of both sides. So the square root of b squared is simply b. The square root of 3,600 is 60. So that means that b is 60. So how many feet from the foot of the building is the foot of the ladder? 60. Okay, so again, the Pythagorean theorem makes it simple for us to find out the side length of any side of a right triangle. Now, let's go into one more example. It's going to be a little bit more challenging, but still simple when we use the Pythagorean theorem. All right, so it says here, the diagonals of a rhombus are 20 and 48. Find the perimeter of the rhombus. So here we have a rhombus here, and a rhombus is a quadrilateral. A quadrilateral is simply a four-sided figure. But this particular four-sided figure has certain properties which identify it as a rhombus. So in this four-sided figure, all four sides are equal. So this side is equal to this side, is equal to this side, is equal to this side. The opposite sides are parallel. So this is parallel to this is parallel to this. The opposite angles are equal. So this angle is equal to this angle is equal to this angle. The diagonals are perpendicular. Here are your diagonals. They're perpendicular, which means that they form right angles, 90-degree angles. And they also bisect each other, which means that this length is equal to this length is equal to this length because they're bisecting. Also, adjacent angles add up to 180 degrees, which means this angle plus this angle is 180, this angle plus this angle is 180, this angle plus this angle is 180, this angle plus this angle is 180. So these properties are going to be necessary, not all of them, but these properties are going to be necessary for us to figure out what our next question is. So it says, the diagonals of a rhombus are 20 and 48. Find the perimeter of the rhombus. Okay, so let's go down here. So now, the diagonals of a rhombus are 20 and 48. So if this diagonal is 20 and it's bisected, that means that this is 10 and this is 10. And if this diagonal is 48 and it's bisected, that means that this is 24 and this is 24. Also, we learned that in a rhombus, these are makes right angles here. So what we have here are triangle. We have four right triangles. Triangle here, a right triangle here, right triangle here, and a right triangle here. And we know what the length of our A, which is 10. We know the length of our B, but we don't know what our hypotenuse is C. So we're going to use the Pythagorean theorem in order to calculate that. So a squared plus b squared equals c squared. So we know what our a is, which is 10. So let me clear this. So 10 squared, oops, put the wrong one. So 10 squared, that's 100. And b is 24, so 24 squared is 576. But we don't know c yet, so we're going to leave that for a variable. So 100 plus 576 equals c squared. We add those two together, we get 676. So 676 is c squared. So we want to know what c is, not c squared. So we're going to take the square root of both sides. So the square root of c squared is simply c. The square root of 676, take the square root of 676 is 26. So 26 is our C. So we know that C is 26. Now, if you remember, one of the properties of a rhombus is that all four sides are equal. One, equal, equal, equal. So that means that if this is 26, this side's 26, this side's 26, this side is 26. So 26 times 4, so 26 times 4 is 104. So the perimeter of our rhombus is 104. Okay, so here are three examples we can use using the Pythagorean theorem to show how we can solve side lengths for right triangles here. So I believe this was a pretty straightforward lesson. If you have any questions, shoot me an email or see me after class. But that concludes our lesson for today. Have a great day. See you next time.